calculus students. Hello, calculus students. What's going on? Okay, we are amping up the area idea. We're taking it to one new level, 3 dimensions. Watch this. Rotate the region bounded by y equals x squared. So that's just a parabola, over 1 up 1, over 2 up 4, back 1 up 1, back 2 up 4. That's your basic parabola. Okay, y equals 0 is the x-axis. The idea there is you can go over anything as long as you go up 0, you're set. So go over anything up 0, over anything up 0. That is a horizontal line. That is the x-axis. Now, the y-axis says it goes, 0 to 2. So the bounds on the x-axis go from 0 to 2. So those are our bounds. So that region from 0 to 2, x squared on top, y equals 0 on the bottom. We're going to take this region and we're going to rotate it about the x-axis. So we're going to pull this point out through the board and rotate it in 3 dimensions. So it's going to end up down here at the bottom. So this is a 3-dimensional surface. Okay, so can you see it? Can you see it? If you set it on a table, the base would be round, and then it would go up kind of like this. So it's a weirdly shaped cone. That's a terrible drawing. So it's this weirdly shaped cone that's kind of archy. So rather than a cone that's like pointy, it's got these weird curved sides. And what's the volume? Like how much clay would you need to make this figure? So it's a 3-dimensional figure. It goes from 0 to 2. Now the cross sections are a circle. So the area of a circle is pi r squared. So pi r squared is the area of a circle. Now, the radiuses aren't the same. So if you start at 0, there is no radius. And if you go out to 2, the radius is 4. So the radiuses change. So we're going to put x squared here. So these are all the radiuses between 0 and 2. The integral adds them up. So if we find this integral, all the radiuses between 0 and 2, and then we plug it into the formula pi r squared, we have all the circles between 0 and 2 making up a volume. So we have from 0 to 2 of pi x to the 4th. Now the antiderivative of that is pi, that's just a constant, over 5 x to the 5th. Evaluated from 0 to 2. 2 to the 5th is 4, 8, 16, 32. So pi over 5 times 32 minus pi over 5 times 0 to the 5th is 0. So it's 32 fifths pi, or 6 and 2 fifths pi might be the best answer. So that's the exact volume. And then if you wanted to order clay to make this thing, you could round pi to 3.14 if you wanted to be more accurate. So we're leaving it up to whoever wants to make this figure out of clay to round pi to whatever accuracy they want to order the clay to make the figure. Something like that. Okay, let's try this bad boy. Rotate the region bounded by x. Oh, wait a second. This one said y equals. So these are the inputs. And this one says x equals. Oh, sorry. I said that backward. This one says y equals. So x is the inputs. I circled the wrong side. Sorry, go back. X is the inputs. So the inputs go from 0 to 2. Here, y is the inputs. So the inputs go from, so if y is the inputs, this axis is the inputs. The inputs go from -1 to 3. This is kind of like the area problems where we look at it sideways. So it's x equals instead of y equals. So the inputs go from -1 to 3. No biggie. Okay, so our inputs go from -1 to 3. The cross section, pi r squared, is a circle. So this is how we set it up. Now, rotate the region, so that's graphed for us. And x equals 0, that's this line. That's x equals 0. About the y-axis, so we have to take this circle and pull it out in 3 dimensions around the y-axis. So the other side ends up over here. So if we pull this circle out in 3 dimensions, we end up with a ball, or more technically called a sphere. So what's the volume of the sphere? Well, I don't know, but it goes from -1 to 3, and it's pi r squared. Now the radiuses change. At 0 is the biggest radius. Out at 2, or in the middle of the ball, that's probably better. In the middle of the ball is our largest radius of 2. So we have a smallest radius and a largest radius. So at 0, the radius is the largest. At 2, the radius is the smallest. So we have all the radiuses from -1 to 3. So our formula, I might need a little more space, is the square root of 4 minus y minus 1 squared, pi r squared. So this here, this represents the area, which is pi r squared. So all the circles added up making a sphere. Okay, let's try it. All right, so let's make it look a little better. -1 to 3. Now, the square root and the square cancel. That's pretty handy. So then we have pi times 4 minus y minus 1 squared. Okay. Well, the pi is just a constant. So the answer is essentially multiplied by pi. So pi times something. You know, like the derivative of 2x to the third is just 2 times the derivative of x to the third. So to save time, I'm going to move the pi out front. And that's a little confusing, but it's legit. Because you're not going to take the antiderivative of pi because it's not pi plus something. If it's the antiderivative of 2, you don't take the antiderivative of 2 unless it's 2 plus something. If it's 2 times something, you just multiply the derivative by the 2. So I'm moving out the pi, -1 to 3. And then it's 4 minus y minus 1 squared is y minus 1 times y minus 1, which is y squared minus 2y plus 1. So then it's -1 to 3 of 4 minus y squared plus 2y minus 1, or -1 to 3 of -y squared plus 2y, and then 4 minus 1 is 3. Okay, so the antiderivative of -1y squared is -1/3 y to the third plus 2 over 2y squared plus 3y. Okay, let's see here. So -1/3 y to the third plus y squared plus 3y, evaluated from -1 to 3. Okay, so plug 3 in. 3 to the third is 27. 3 squared is 9. Plus 3 times 3 is 9. Now plug -1 in, so it's -1/3. -1 to the third is -1. -1 squared is 1. And 3 times -1 is -3. So 27 times negative 1 is negative 27. Divided by 3 is negative 9. Plus 9 plus 9 minus negative times a negative is a positive. So it's 1/3. 1 minus 3 is minus 2. Negative 9 plus 9 is 0. So I have 9 minus 1/3 plus 2. Okay, 9 plus 2 is 11, minus 1/3 is 10 and 2/3. Now, I'm missing something. This pi, I didn't write down each step. So there's a pi there, a pi there, a pi there, cha-cha-cha-cha-cha-cha-cha-cha. So it's 10 and 2/3 pi as my final answer. Now, that was a bit of a doozy, and there's a decent chance I made a mistake. So since the shape is a sphere, I could use the formula from geometry to check my answer. The volume of a sphere, if I'm not mistaken, is 4/3 pi times the radius cubed. That's the formula from geometry. Now, this formula from geometry isn't nearly as exciting as the calculus. The radius of this sphere, okay, let me clean this up a little bit. The radius of this sphere is 2. So if I plug 2 into this formula, I should get the same answer. 2 cubed is 8. So it's 4. I'm a little nervous, actually. 2 cubed is 8. 8 times 4 is 32 thirds pi. 32 thirds is the same as 10 and 2/3 pi. Holy cow, I have done it. You can't believe it, and neither can I. Good luck.